Okay, in some section there are circles. Ma'am had started circle. Can I explain, students? First, let me know what you all understood. Whoever knows, you all can explain the concepts you all studied. Ma'am taught in circles. Respond. All of you will respond. Those who know, respond, students. Tell me, Amy, Kia, Delicia. Only theorem. Okay, segment theorem, segment sector theorem. Fine. See, before that, okay, fine. Before that, you should know all the properties of circle. We'll start with basic concept, all the properties. This is a circle. Okay, this is the center. From center to circle, this one single line, what do you all call this? We call this radius. All these are important concepts. Without this, definitely you won't understand circle chapter. Radius. Next, we have n number of radius. Example, this one bicycle wheel. From center, whichever touches the circumference. This outer part is known as circumference. Fine. From center, all these are radius. We have n number of radiuses here. All these are radius. Center, I'll write it as O. I'll take radius as R1. There are a lot of radius. R1 is equal to R2 is equal to R3. The values will be same. If R1 is 5 centimeter, definitely all the values are 5 and 5. Okay, this is radius. Now next, tell me diameter. What do you mean by diameter, students? What is diameter? Hmm. Very good. Touching the circumference. This is known as diameter. A diameter is basically two radius put together. Two radius which is straight. See, if I take this, this is one radius, this is one radius. This doesn't become a diameter, students. A diameter should touch both the sides of the circumference. This is radius 1, and from here I'll join this. This is radius 2. It should be a straight line. This is diameter, a straight line. So basically, diameter is nothing but 2 times radius. 2 radius put together is diameter. So diameter is equal to, the formula is 2 times radius, 2r. 2r is diameter. Same like radius, you have n number of diameters. This is also diameter. This is a diameter. A diameter will always pass through the center. All these are diameters like this. Whichever doesn't pass through center, if I draw a line, is it passing through center? Response, students. Is the pink line passing through center? No, right? But isn't it touching the circumference? Yes, it's not a diameter. Pink line is not a diameter. See, it is touching the center, I mean circumference, but it is not the diameter. So the green lines are diameter. What about the pink line? What do you call? Whichever doesn't pass through the center but touches the circumference. What do you call that? Very good. What do you call the pink line as? We call it as chord. So what is chord, students? Chord is not a diameter. Okay, chord is not a diameter. Chord is a line which doesn't pass through the center. Fine. Chord, it doesn't pass through the center. Apart from center, it has to touch even the circumference. All this, the pink ones are chord. This, like this is a chord. If I draw like this is a chord. All this. Okay, even the center one, even if it passes through the center is also fine. Even this is a chord. So diameter is also a part of a chord. Diameter is the lengthiest chord. See, everything is a chord here. In that specifically, diameter is the lengthiest chord. Diameter is the lengthiest or the longest chord. Longest chord. So basically, chord is a line which passes through the center as well as apart from the center, students, any other direction. We call it as chord. Let me mark it again. See, This is the center. A line which passes through the center, what do you call this? All of you will respond. What do we call? Yes, this is also a chord. It's also a chord, but specifically what you call if it passes through center. It's a specifically diameter, but it is also a chord. Okay, everything is a chord today. Whichever touches from one end to end, the other end, it is a chord. See, when this is a chord. The green one is also a chord. Specifically, we call diameter. In the same way, the pink one is not a diameter, but it is a chord. All the pink ones, see like this. It's not passing through the center. It is just away from that, like this. Right? Out of all these lines, the longest line will be the green one. If this is 5 centimeters, if this is 7, if this is 8 centimeter, the green one will be 9 centimeter. So remember this, anything which passes through the center, that is the lengthiest chord, students. Okay, that is the longest chord, and that is what you call diameter. Right? Write circles, put the chapter heading as circles, draw a circle, write what is diameter, radius, write the formula for diameter. Is it clear? Did you write what is chord, students? Shall we do the next concept? Next one. So I'll just write whatever we complete. First thing, we started with circle, and one more thing. Any line which lies inside, we call interior. Any point which lies inside, what do you call these points? A, B, C as interior or exterior? These are interior points. Anything which lies outside, because circles will continue, and there is a concept called tangent. Even that is important. So remember, point E, point F, all those are exterior points. ABC is interior, EF is exterior. Next. So we started with circle, we studied what is radius. Radius stands for R, and we studied what is diameter. Diameter is D. The formula for diameter D is equal to 2 times R. Then we finished chord. Next concept. See, everything is just continuous. Everything just continues. I told you all this line, students. See, what is this line known as? Diameter or chord? Chord. What is this chord? Extends outside. A chord will never extend outside. It is always inside. Fine. Remember, students, a chord point will lie on the line. A is one point, B is another point. The points will lie on the circumference. This is known as chord. So whichever comes out of the circumference, what do you call? Whichever comes out, what do you call? Any guess? A line which passes from outside, it has one point outside A, one point on the line. No, it's not tangent. What do you call this line as? Just a minute. Just a minute. Hello? Okay, what do you call this line, students, which also passes out like this? We call this line as secant. Okay, make a note. Whichever passes out, we call secant. Fine. I'll tell you what is secant. Next tangent. Yes, I'll tell what tangent meaning is. Is secant clear? Is it clear? Okay, next concept. So we'll go step by step. Radius done, diameter formula is done. We know what is chord. A chord passing outside we call secant. Okay. Next thing, arc. What do you mean by arc? If I take any 2 points on the circle, students, this point, A here and B here. Arc is a part of a circumference, not the complete circumference, just a part. This part is called arc. And we have two types, minor arc, major arc. Minor arc is from A to B, this direction, this one, the green one. Apart from that, the circumference has other value, this one. What do you call this one as, major or minor? Major. What is major meaning? Or what is minor is smaller, major is larger. Yes, major arc, minor. We don't tell smaller arc or bigger arc. We tell major arc and minor arc. Yes, make a note. Arc is basically 2 points on the circumference. If you want to write the definition, 2 points on the circumference is known as arc. So chord is done, secant is done. Next we'll have segment, sector. Is it clear? Next concept. You heard about this line. Angle subtended by an arc. Did ma'am explain anything like that? Angle subtended by an arc. What do you mean by angle subtended by an arc, students? Did you learn all this? Okay, fine. Let me take arc A and B, the green line. Look at arc A and B, the green line. What do you mean by angle subtended by an arc? This is arc AB. Angle subtended is these two lines, if it meets here, like this, the center. This angle, it can be 10 degree, 20 degree, anything. What's the total value of a circle? What's the total value of a circle? It has 360. So this could be 50 degrees. AOB. This is the angle subtended by an arc. We write it like this. Angle A. Starting point is A, students. From A it goes to O and back to B. So answer is 50. This is the angle subtended by arc AB. And for arc we draw like this. I think arc, yeah, like this. This is how we represent arc value. Arc AB. If they ask you what's the angle subtended by arc, what's the answer? AOB is wherever the arc touches. Now let me take another arc, C. Okay, I'll take C here and I'll take D. Imagine C and D. They are the second arc on the same circumference. Second arc on same circumference. I'll shade it with the pink. Look at the pink one. That's the second arc. If I touch this in the center, now tell me what is the angle subtended by CD? All of you will respond. What is the angle subtended by arc CD, students? COD. Is this clear? This is the angle. So which one you think is greater? Angle AOB looks larger, right? So from this we have understood the angle subtended depends on the arc, student, size of the arc. The greater the arc, the greater the angle subtended. Okay, the greater the arc, the greater the angle subtended. Subtended is nothing but extend. Remember the word subtend and extend. You'll know what is extend, right? Extend is increase. And remember like that. Subtend is from the point to the center. It touches from point to center. So the angle subtended depends on the size of the chord, students. Chord. So today I'll explain all the concepts. Tomorrow we'll start solving. Is this clear? Understood what is arc and arc subtended by chord? I mean arc, angle subtended by chord. That is the next concept. These are the most important parts, students. Now what we are going to do is the most important. Important what? Do one thing. Arc and angle subtended, I'll keep it separately. That's a separate concept. Right? So write this order: radius, diameter, chord, secant. Next one is segment. Segment and sector. These are the two important. Based on this only, you'll have two formulas: segment formula and sector formula. Now I'll explain what is segment and sector. Let me take a circle. I'll draw a line like this. I'll name it as A and B. Okay. Now tell me, what is this? Is it a chord, sector, diameter? What is it? A chord, right? It's not going outside and it is not touching the center. Fine. It is not a diameter, but it is touching from one circumference to another circumference. Clear? So the arc, students, what is the arc here formed here? What's the arc formed? All of you respond. What's the arc formed here? Arc is AB is the arc, right? AB is the arc. So this arc AB touches the chord. This arc, I'll name it as AOB. Fine, I'll name it as AOB. This arc is touching the chord A and B. This is what you call segment. This entire piece is segment. If I cut this out, if I take it out, okay, this is a segment. So arc is different, segment is different. A segment is made up of what, students? Tell me, a segment is made up of what? Arc plus chord. Yes. And this is a minor segment. This is small. The same segment, the same line AB, imagine there is another arc, the major arc. This is the major arc, pink one. So this arc circle is split into two parts. One is like this, the bigger one, and one more is smaller one. So this is known as minor segment. The other one is major. Once you are thorough with all this, those two theorems are very easy to solve. Right? Minor segment, major segment. Minor, this is major segment. So are you all thorough with segment, students? Meaning of segment? So, yeah, what is segment? Segment is made up of chord. Next, sector. Remember segment and sector. This is where students get confused. In sector, remember the word R. Okay, let me teach you what is sector. Just remember the word R. R stand. Remember R. Just imagine R. I mean, example. Just think R stands for radius. So I'll take an arc. I'll mark arc here A, and this is B. So this is the arc, students. Arc AB. So sector is nothing but it is made up of arc plus to radius, not chord, arc plus radius. What do you mean by that? I already told you arc subtended. This becomes the sector. So two radius. What is the first radius? From center to AO, what do you call AO, students? AO is also radius, right? R1. What about OB? OB is also radius R2. So this entire portion, what do you call? We call it as sector. For example, all of you have had pizza. Have you seen a slice of pizza? Not triangle. How can it be triangle? Yeah. Yes. Top triangle and down we have arc, right? A slice of pizza, students. That is exactly sector. One sector. So imagine this is entire pizza. From that I'm going to remove one slice. One slice is gone. This part is what you call sector. So if you convert into mathematical, this one circle point, this becomes radius. This is radius. So a sector, remember R is given. It has one arc and two radius. This is sector. When it comes to segment, it is a chord like this chord. This is a segment. So write it. I have explained. Write it however you want. What is arc? What is angle? And if you talk about angle, what do you call this angle? A and B. What do you call angle subtended by which arc? By arc AB. This is the angle, students. So sector is different. Angle subtended by arc is different. Is it clear? Understood? So what doubts do you all have? Sector, segment clear? These two are very important. Sector and segment. Any doubts in this? Radius, diameter, chord, sector, segment. Angle subtended by an arc. What is arc? Everything. Yeah, shall we start the theorem? First theorem. I'm just going to explain basic. There are a few more concepts left. There is still tangent left, concentric circles, equal circle. Okay, all this we'll do it next. First in circle, whatever we have done, that is enough. First theorem, theorem 1. For your syllabus, there are only two theorems. So theorem 1, you can call this theorem as sector theorem. Remember as sector theorem. So what is sector? Tell me what is sector, student. Sector is made up of what? Yeah, two radius and one arc, right? Okay, sector and segment. Sorry, sector and no, I made a mistake. Sector, I told you all. I missed out one concept, students. I missed out one. In this circle, okay, in this, if I take arc AB, fine. If I take arc AB, if I touch in the center like this, what do you call this? A radius, right? We call it radius, radius 1 and radius 2. What do you call this entire thing? We call it as no, entire thing, AOB. A slice of pizza of sector. So whichever line touches, we what do you call in the center? We what do you call sector. In segment, there are two types. I forgot to explain that. What is segment, students? What is segment? one like this. This is a segment, right? Chord. Yeah. One more thing, like this. If I touch like this, even this is a segment. The reason is I'll take O outside. Okay, this point. What is O and A? Is this radius or chord? O and A. It's a chord. What about OB? Chord. Even this is a segment, not sector, segment. This is a segment. So segment is of two types. It doesn't touch the center. It touches the circumference. So segment is made up of what? One arc plus how many chords? One arc plus two chords. Sector is made up of arc two radius. Okay, arc plus two radius. See, this is segment. If it is radius, it'll touch the center. So the blue one is the segment, student. Segment. Now I'm going to draw a chord in the same one. The green one is the sector. ACB. Look at ACB. ACB is the sector. AOB is the segment. Right? So starting it might be little confusing. All you have to remember is this concept. What I've written. Sector is arc plus 2 chord. Segment is arc plus 2 radius. Just remember that. Ignore all the other points. Is this clear? Shall we do the first theorem? Theorem 1. See, theorem 1, they explain in textbook, it is different. Teacher, how did teacher explain? Tell me. What did you all understand, students? What is theorem 1? Anyone can answer, whoever attended. Tell me, what is theorem 1? Yes, respond. See, you're told you all attended. Nobody knows what is theorem 1? Amy, Kia, no? Okay. In short, I'll teach you all, students. See, just remember center. Center is equal to twice 2 times circumference. Just remember this. Center is equal to what? 2 times circumference. Now let me take an arc. I'll explain what is the center. This is not the theorem. This is a theorem. The name is not given like this. This is how I explain, students. Look here. Center is equal to twice the circumference. I'll take an arc AB. What do you mean by center, students? If I join this, is it a center? Sector or segment? Radius. Sector. This you also remember as sector is equals to twice segment, 2 times segment. See how the concept gets related. I'll take the same arc AB, I'll take the same arc is equal to twice segment. I'll draw a segment or circumference. What do you mean by circumference? I have to connect it to what? Circumference. So what do you call this line? AC, students. AC is what? Arc or chord? AC is a chord if it is touching the circumference. So do you call it segment or sector? AC and AB. So the formula is the angle formed in the sector. Look at the angle subtended. What's the angle formed in the sector? Angle AOB is equal to 2 times. What's the angle formed in the segment? This is the formula. This is how we'll have to study. Center is equal to twice circumference. We know whichever angle forms in the center, that is sector, radius. Or you can even remember sector is equal to twice segment. Angle AOB is equal to twice angle ACB. What do you mean by that? If angle ACB is 50 degree, read this and tell me center is equal to what? 2 times circumference. So if ACB is 50 degree, AOB will be double, 2 times. What do you mean by 2 times? 100 degrees. So basically we are finding the angle, students. That's it. Sector is equal to 2 times the circumference. This is the first theorem. You all understood or you want me to explain again? Then again, okay. What you have to remember? The first theorem is center is equal to twice circumference, 2 times circumference. Now what do you mean by center? Take an arc, connect it to the center. What is the angle formed here? Angle, that is sector. Name is sector. What's the angle formed? Angle subtended. AOB. I'll take the same arc. Remember, you don't take different arc. You take the same arc. What is 2 times circumference? This should touch the circumference, right? What's the angle formed in the circumference? ACB. This is the formula. AOB is equal to ACB. The meaning of that is, if AOB, if I write it as 80 degrees, students, 80 degrees, AOB is 80, is equal to, see, AOB is 80 degree. If AOB is 80, what is ACB? It is just half of it. What is the value? Yes, look at, if I substitute in this equation, bring 2 down, 80 divided by 2. What is ACB value? 40. So it is basically angles. Theorem 1 is all about finding angles of same arc. Same arc. So it is a very lengthy derivation they have given, theorem 1. Just ignore all that. Remember, center is equal to twice the circumference. This is theorem 1. So if you cancel this, what is the angle formed in the circumference, students? ACB is equal to how much? 40 degrees. Is this clear? All of you all understood? Correct. Yes, make a note, write theorem 1. I'll give you the definition, the theorem, what the exact line is. But you all remember like this, center is equal to 2 times circumference. Write the formula. AOB is equals to 2 times ACB. So basically finding angles, student, that's it. We need to find their angles. Okay, shall we try the next one? I will complete it. This. Fine. Look at this and tell me, students, which is the arc here? Which is the arc we have taken? Which 2 points? PQ is the arc. I want all of you to respond. PQ is what? Arc. On the same arc, which is the line which is touching center? Which angle is that? Angle OQ should be equal to, according to first theorem, should be equal to what? 2 times. What is the angle formed in the circumference? Which is the line touching the circumference? Tell me, start from P, which is the L, Q. So what's the concept, students? The angle formed in the center is always double. If it is 60 degree, what will be the angle formed at PLQ? No, center it is double. Center is double. Center is always greater. Double. So L will be half of it, right? L should be how much? L should be. See, let us substitute equation. What is POQ value? POQ is how much? 60 is equal to 2 times PLQ. If you want to find PLQ, what happens to 2? 5. Answer 30 degrees. Remember, center is always greater. Center is equal to 2 times circumference. So they'll ask question like this. If not, they'll give you circumference value. I'll give circumference as, look at this, students. Even without using formula, you can find. But board exam, for 3 marks, you have to definitely use the formula. The angle formed in the circumference, if I give it as 35 degrees, what will be the value in the center? Will it always, center is greater? So if this is 35, what is the angle formed in the center? Just use the formula. Center is what? 2 times circumference. So if you want to find the angle in the center, 2 into what's the angle formed in the circumference? 35. What is 2 times 35? 70. This is 70 degree. Isn't it double? Right? So remember the center, it is always double. Circumference it is always half, students. Half of it. For center always double it. Circumference it is always half. Here, okay, I can hear only some 2 or 3 students answering. What about others? Cecilia, did you understand? Angel, Abigail, Delicia, Anya, Malavika. One of the tough topics, students. So we have started basic. Don't ignore basic. Okay, if you don't understand this, future whatever we study, this will take at least 15 days to complete this chapter. So if you miss out the first class or any 1 or 2 topics, definitely you won't understand the entire chapter. You'll have to skip. And circles you'll get circle and tangent both put together 8 to 12 marks. Very important concepts. 8 to 12 marks chapter. You'll get 1 3-mark question, 1 2-mark. I mean 1 4, 1 MCQ. So if you learn circle, it is almost equal to learning 2 chapters. It's a lengthy concept. Okay, this is the first theorem. Understood first theorem? Shall we do the second theorem? Fine. Yeah, I was not able to hear her answering. Fine, Abigail. Next, theorem 2. And theorem 1 and theorem 2, the entire sentence I'll give tomorrow, students, or you can just go through your textbook. In short, remember what I teach. Circumference is equal to circumference. Just remember, in short, what do you mean by circumference is equal to circumference? Just by this line, can you give an example? What did you understand by circumference is equal to circumference? That is concentric circle. Relate it with theorem 1. Let me take A and B. Just think what would be, why did I write circumference is equal to circumference? Angle formed in the circumference. Yes, angle formed in the one circumference is equal to what? Angle formed in other circumference. The concept here is arc. Arc should be same, students. This is the second theorem. In the same arc, I'll take one angle subtended here, ACB. On the same arc, I'll take another angle here. This is the concept of second theorem. What is circumference is equal to circumference? Now can I answer? If this is 50 degree, this one should be 50 degree. This is the concept. Angle ACB is equal to what? Angle ADB. And what do you call them? Sector or segment? Is it chord or radius? Very good. So this concept you can also remember, segment is equal to segment. Forget about theorem 1, theorem 2. They don't ask theorem 1, theorem 2 in exam. They'll give you a diagram, you have to follow. You have to find the answer. Is this clear, students? Yeah, make a note. Right, segment is equal to segment, or circumference is equal to circumference, right? Whatever you all want, this is the concept. That's it. It's only these 2 theorems. Along with this, you'll have a lot of concepts to solve. Okay, another 1 minute left. Be quick. I'll ask you all one question. We'll end the class. We'll continue tomorrow. Make sure arc is same. The arc should be same. Only then you can apply theorem 1 and theorem 2. Right? In detail, I'll explain tomorrow. All of you, did you write theorem 2, students? Theorem 2 is done. Understood? Quick last question. See, you will get a diagram like this. Example MCQ question. They'll ask you to find angle POQ and angle PBQ. Who can answer? On the same mark, which value is given? Circumference value or center value? Which angle is given? Which angle I have marked? I want all of you to respond, students. Which angle did I mark? PAQ is 30. PAQ is 30. Apply first theorem. What is first theorem? Center is equal to circumference, right? 2 times circumference. So, what is the angle formed in the center? POQ. Very good. Direct answer. Then apply second theorem. What's the angle formed in the circumference? This is the answer. Which theorem we applied to find PCB? Circumference is equal to second theorem. And I don't remember. I don't remember the exact definition of second theorem. This is how I learn. This is how I teach. Okay. What about the first one? Segment is equal to twice circumference. For PBQ, I use circumference is equal to circumference. Is it clear? So, what doubts do you have, students? What doubts in this? No doubts? So, what you'll have to learn, and it doesn't matter whether you learn theorem 1, theorem 2, or theorem 2, theorem 1, order doesn't matter. What are the two things you have to remember? Segment is equal to twice circumference. The other one, circumference is equal to. Very good. Anything which is formed on the circumference, segment or sector, what do you call it? Segment. A segment is made up of what? Arc plus chord. That is what forms in the circumference. What about sector? Sector is made of what? Yes, arc plus radius. So this is center is equals to twice the circumference. So both these theorems are done, students. Okay, was it easy or tough? Yeah. It is easy, right? So it depends on how you will study, how you will understand this. If you learn by this method, you will understand. Okay, we'll continue tomorrow. That's it for today. Attend at 7 o'clock tomorrow. Clear?